All right, this is amazing. They have not had Armington and Sims Machine Shop open in like 3 years. This is understandably my favorite place in the entire museum, and I have not been in this building in at least 3 years, so I am stoked. Yep, they got the line shaft going. Yeah, what do they call those, Wiggles? Shaft mice, remember? Those are called shaft mice. Okay, there we've got a nice old 21-inch Cincinnati drill. Got a little Pratt & Whitney horizontal mill here. Oh, what do we got here? I don't see a name on this. I mean, obviously it's a shaper. I just don't know what brand of shaper. A Beck vertical mill. That's pretty cool. What do we have here? I don't see the name on this one, and they don't put tags near them. Oh, what do we have? I think this is a Lucas, Wiggles. It is. This is a Lucas horizontal boring mill. I'm not sure what model this is. The bed makes me think it's a Model 41, but the short column makes me think that it's, I don't know, unless it was a special of some kind. The bed design is very similar to our Lucas Model 41, the design and size of it. I don't know what they've got that big honky cutter on it hanging out like that for. Like, I have a hard time believing this machine would have actually been used in that manner, but I don't know, I've been wrong before. I don't know what, oh, we got, what is that, a OD grinder there, another grinder. Man, I wish I could see the other side of this Lucas. I'm quite curious what model that is. So you can frequently turn your own candles here. They've got this little production turret lathe set up so that you can do candle turning, or candlestick turning, I should say. They don't appear to be doing that today, but it's, as I recall, pretty straightforward. They've just got a big profile cutter in it. Plunge in, cut the entire profile in one pass, and then they've got this set up to go in and do the various functions for drilling the pocket for the candle. See, they've got some finished ones there. Oh, cool. Here we've got a, let's see, Powell Planer Company, little bed planer. Unless it's got junked, I know where there's one of these at about this size that I really would like to go talk to the owners about getting. A.B. Pitkin, we've got a drill press, and then hiding behind it is, what is it? The W.E. Gang Company radial arm drill. So we have mechanical, what is this, punch press? Thomas and Lowe lathe. There's something I want to show you guys when we get to Edison's machine shop. There is something there that I really want some input on that's baffled me every time I've seen it. Oh, here we've got, look at this. We've got a big planer with a baby one sitting next to it. That is cool. Hendy Machine Company. I'm sure there's some Hendy guys out there that are going to go nuts when they see this. And then the other one is, what is that? Mill Pond Machine. I can't quite read. The Pond Machine Company. That's what the big one is, but man, that Hendy is cute. That is slick. Here, I'll back up and get a picture of you next to it. Look at that. It's a little tiny planer. What do we got on the other side here? A.B. Pitkin again. Nice big lathe. Oh, look at this. Vertical turret lathe. That's another Pitkin. That is a gorgeous machine. A lot of these machines are almost brand new. They did teach trade school out of this during World War II, but Mostly, I think Henry Ford bought these machines all new or as close to it as he could get them just for this display, so pretty impressive. There's a very early horizontal cutoff saw. Oh, big gap bed lathe. Impressive. Oh, here we have a vertical slatter or vertical shaper, depending on your preference. It's got the automatic indexing function on it. Very cool. Look at this. Oh, here's the steam engine that drives all of this.
If all of our piping was reconnected, yes.
I don't want to say it in here because I don't want to freak them out, but this engine is the probably the main reason that you don't see engines running at Greenfield Village. Back in the 1980s, this machine decapitated a volunteer as people watched. He was wiping something off with a rag, sucked him in, 80-some-year-old guy. So pretty gruesome event, and Greenfield Village, to the best of my knowledge, it basically ceased running anything under steam power since then. It's a real bummer because you never get to see these engines run. So what is this? Oh, this is a huge hammer. Bradley cushioned hammer. That's a whopper. All right, Wiggles, do you think you ought to make a candlestick?
Huh?
Think you can, should you make a candlestick?
How?
We'll go see. So I got a couple of small steam engines here. This one appears just to be set up on display, but then they've got a small one here that can run the line shaft. I assume the point of that was that they could conserve steam when they weren't running something that needed the big horsepower. As you can see, they've got belts going up through this box, the overhead shaft here, but they also are capable of driving that system through this one. So I would assume any of the smaller machinery, they'd just run it on this steam engine instead of big hog. And then, by the way, this is the boiler here. Then something else interesting, they've got a early overhead crane system here. I've never noticed this before, with a chain driving seat to crank the thing back and forth, so the entire length of the building is served by that overhead crane. It doesn't reach out into the side wing, so you would have to somehow manhandle stuff from the center aisle out to the machinery, but pretty cool. Wow, they were nice enough to let us behind the barrier. What did you say, 1914? Oh yeah, Lucas 31, so this is the direct ancestor of my Model 41 then. That is so cool. Yeah, we're still regularly using mine. The newest machine in my shop's the 1978 Bridgeport my dad bought, but I love old iron, so I'm intentionally scrounging the old stuff up, putting it back to work. One of the greatest regrets of
the steam pump, and through the action of pistons, that water gets forced back up into the boiler above the pressure of the operation of the boiler itself. It's called a positive displacement water pump. And many operators found out the hard way that you don't close the valve on a water pump, because water is a non-compressible fluid. You can't make it smaller. Unlike air, you can make air smaller, because water is not.
All right, Wiggles and I decided to come over here and check out. They got the railway crane parked here on a siding. I don't think I've ever seen this move, so I'm kind of assuming it's not operational, or at least hasn't been operated in a very long time. Here they got their Plymouth shuttle engine parked on the siding. And here's the roundhouse and the round table. And this is what Wiggles wants to see. Yep. So this is the roundhouse. I don't think you can. They haven't had this open in quite a few years. You used to be able to go in and go up on that catwalk along the back, unless they've opened it back up.
What's that?
That's a little rail car. Let's see. Holy smokes, look at that radial drill, wouldn't you? That is a whopper. You see a shaper in the back corner. You can't see it very well from here, but they've got a big lathe back here. See if I can zoom in. I assume for turning the wheels on engines. And then they've got a big lathe or two in here. All the equipment they need to service the engines. Pretty cool. So we'll get in here a little later after we ride the train. That's a 1888 Edison power plant over there. All reciprocating steam engines running DC generators. We'll get in there on hopefully after we get done with our train ride and go hike around a bit, show you the insides of that. It's a pretty cool place. All right, so Wiggles and my wife decided to go over. Wiggles wanted to ride the carousel. So Cupid and I, he's taking a nap. We're going to stop here and check out Edison's power plant. This is another one of my favorites just because I like mechanical things, the steam engines, the dynamos. Pretty cool. So this is kind of where it all started. They've got big magneto-style dynamos in here. Flat belt drive off from compound steam engines.
Welcome to Station A, Edison Illuminated. This is a powerhouse that creates a form of energy called direct current. This is a typical powerhouse you would see in the late 1880s, moving all the way up to the turn of the century of 1900 when we switched from DC power to AC power, alternating current. And we're still utilizing alternating current today. With that stated to you, this particular powerhouse is a quarter-size replica of the original Station A that we had in downtown Detroit.
No kidding.
All the appliances you see in here are all full size. They just would have had more of them at the original Station A.
Wow, very cool.
With that stated to you, direct current starts in the boiler room. The boiler room cooks the water, creates steam. Steam has been pressurized by coal firing, it's on the left, oil firing is on the right. Once that steam has been pressurized between 100 to 200 psi, pounds per square inch, it can be sent over through the overhead pipe system to the steam engines that operates that process. The steam engine then controls the big flywheel. The flywheel controls the belt. The belt is connected upstairs in the second floor to what was called the dynamo. Today we call the dynamos generators. This picture that's on the wall over here showcases to you what the second floor looks like. Those are 50 kilowatt dynamos. They're upstairs. They supply the energy for this particular powerhouse. But what are the
Armington and
dynamos?
Sins.
The dynamos are electrical magnetism. If you take two magnets, you put
1887 is the right year for that.
Belt systems and stuff are usually in operation.
So there would have been coal here.
That's over there.
There would have been a fireman shoveling 750 pounds of coal into that hole every hour during the time.
Is it working today?
An hour.
Well,
They only had to work half the day.
So it should be.
So when this 12-hour
Okay,
shift was up,
thank you
you
so
paid
much.
50 cents cash.
Not the guy you wanted to arm wrestle down at the pub that night.
Well, I didn't have to work every day. There was a line of people out front. The same guy wouldn't work every day. But the coal here is chemical energy. Throw it in there, burn it, you create thermal energy. Heats the water in the tubes inside here to create steam. Steam pressure goes through these white pipes over to that steam engine.
This one and bicycle shop number 4 are the white two that still exist.
Here it is, Wright Brothers Bicycle Shop.
It's in Dayton, not too right around the corner from where there's Boyhood Home.
So here we get to see a model of what they're so famous for.
It's no walking distance to where they're
Plane they flew at Kitty Hawk.
Most of the cycle shops are within that area. That's the national park. Yeah, we can all park out here, reconstructed it, and or go around so you can actually come to the reconstruction. Oh, cool. And so a lot of the
Here we have a model of a wing section from their airplane. Oh, this is cool. What do we got here? This looks like a hot tube engine of some type. Not familiar with this engine. I'm assuming it's an engine, not an air compressor. Yeah, it's an engine. Yeah, it's hot tube ignition. Oh, here we got a little Camelback drill press. What does this say? F&J Barnes Company, Rockford, Illinois. Come on, Riley. Vertical bandsaw. Oh, here we have an unfinished case made out of aluminum. There's a model of their airplane engine. All right. Got a lathe here. What is it? Putnam Machine Company. Nice old flat belt lathe. Very cool. So a lot of history here. Like I say, I can't express enough that if any of you ever have a reason to come wander around on the east side of Michigan, you really got to come to this place. We haven't even touched the museum yet. This is just the village, so very impressive. All right. This is the Menlo Park Complex. So, here we have the boiler room for Edison's machine shop. Impressive. 18 is Edison's machine shop. Alright, here's the main engine. 75 horsepower Babcock. Alright, had to restart the video because Cupid was yanking my beard out by the fistfuls and it was making it hard to steady things up. So they got a big main engine and then they got a smaller engine here. Once again, I would assume for when they're running less machinery. So let's see here. What do we got in this place? Got a typical ratcheting arbor press. Greenard arbor press, number 3.5. I believe it's a Greenard number 4 that I've got in my shop. I'm not sure what that lathe is, but here is what I am really curious to get everybody's input in. So, sorry for the shaky. I got a baby jumping around here. See this? I do not understand the point of this. This cross slide kicks up at a taper. I don't understand what the point of that is. I'm quite curious if anybody out there has seen that feature. This lathe has it. The one across behind it has it, where you can tip the cross slide up. I don't really understand what the point of that is. And I've asked the staff members here, and they don't either. I have never personally seen another lathe with that function on it. Oh, here we got a gang drill, 2-head gang drill. Pretty wild. Oh, another metal planer, about the same size as the one over there at Armington and Sims, maybe a little bit smaller. Horizontal milling machine. Oh, here's Camelback drill press. I don't know whose model it is. I can't read the tag. And here we have more of a production type drill press. The flat belt lathe, I don't really, I say the tags are all facing away from me. Wow, that's quite the grinding stone. Pretty cool. Oh, and then we got a power hacksaw. Another lathe. You know, that lathe also has that tilting cross slide. I just don't get it. Unless, the only thing I could think of is that maybe that's a rapid way to change your tool height. That it's not actually for cutting tapers, it just gives you a quick way to change tool height. I'm not really sure. It's a new one on me. Oh, that's a cute little drill press. Here's the woodworking shop at Menlo Park. Oh, that's interesting. They got a machine in the back for making, I'm pretty sure that is a, makes acetylene. See here, lavatory gas, did they say? Assuming that's one of those where you react calcium carbide with water and make acetylene. Oh, it's a cute little jigsaw. Got a wall-mounted drill press. Jigsaw, treadle-operated lathe in the back there. That's pretty neat. And then this is a flat belt drive table saw. Interesting.
Like I said, it intrigued me to the degree that I had to look it up. But once I looked it up, I couldn't understand what it said. This is his original equipment that he turned the lights on with the very first time.
Oh.
His boiler created the steam, went over to this steam engine. The whole thing is first power plant. Steam engine. A belt was attached, went to the overhead, that drove this belt, that turned this copper drum inside two big magnets, creating an electromagnetic field. When you put the brushes on the spinning drum, the friction acted with the electromagnetic field to create static electricity. The static electricity would go up into these metal columns wrapped in copper, dynamo, and it'd be stored there like in the cartoons. When they were ready, wires were attached to these two leads that would take it out to whatever building or machine they wanted to light or turn on. Throw a switch, everything would go. You were golden. And
It's a
this
stone crusher.
is the real
Ore crusher.
equipment that he used the very first time to turn the lights on.
Pretty cool. Got an ore crusher back here.
One of his big goals was for his men to never have to wait if they needed something for an experiment. He didn't want them needing gold, having to write to California.
Edison's lab.
Sounds good. I'll go get the office.
Yeah,
Edison's phone.
Yep.
All right. You're going to go upstairs with Wiggles?
Sure.
All right. Cupid and I'll stay downstairs.
All right.
Interesting. There's a little duplex steam pump. Using it to operate this press. That's pretty cool. Old school hydraulic pump.
Yeah, run off a steam engine.
Yep. Was that old enough it was using water as the fluid? I know a lot of the old days they didn't use oil. They used water as the working fluid.
I'm going to guess they had some sort of hydraulic fluid.
Huh.
Reservoir off to the side.
Oh, gotcha.
When I used to come in here, I used to think that was a heater. Like they had steam run into that. So they used to come in and then play them back. Edison hears that, operating, realizes it's making a sound that he misinterprets as a voice. So he reverse engineers it. The invention he invented, built, sells it to Western Union. But he takes the essence of that and figures out that the sound is coming from vibrations in the air. He's going to capture vibrations onto a piece of film. This is mica. It's going to make this needle move in and out, gives a direction. So that when it passes, the needle is vibrating and it's passing by the foil's being turned. It records where the depth of the needle at any given point. So when I turn the needle back across those bumps, just like a record player, it makes the needle vibrate, makes the film vibrate, which makes the air vibrate when you hear the sound. The same sound that creates the bumps in the points. So it's reversing that whole process. Yeah. But this is the machine he invents in 1877 that gives birth to audio recordings of any kind. People do this. This is a device by the Bergman Company in 1878, built under contract by Edison. And so they made about 200 of those that year. Most of them leased out for $100 a year. 9 left in the world, 5 of them here in the museum. This is the only one of those 9 that functions. Cool. If you want to see more about this, Innovation Nation, our first season, had a great episode with Mo Rocca and one of our deceased presenters, Jerry Davis, talking about this and recording on it. It's a really good demonstration of that machine. So it shows Innovation Nation, and if you look up Innovation Nation and phonograph, you'll get this.
Great.
Awesome. Thank you.
Welcome.
Thank you so much.
Absolutely.
All right. Well, we're done for the day. I just felt a drop of rain, so I think the timing is good. So we're just hiking out of Edison's Menlo Park here now. And we'll be back tomorrow and see some more sights. But good time was had by all. As I'm sure my more technical audience members will notice, I try not to say anything while I'm in there, but a lot of the presenters, you know, they're volunteers, and their grasp of the things they're describing isn't always thorough. I mean, any of you that just watched in Edison's lab know that static electricity is not what is generated by dynamo. It's DC current, yes, but the description of how that old DC dynamo worked was pretty bad. But Anyway, you got to cut them some slack. They're trying, they're volunteering, they're helping the kids and the rest of us learn something, if not the correct thing. So anyway, that's it for today.